Howdy everyone, welcome to the first ever virtual National Weather Festival. Things are a little different this year, but this format will allow us to give you a behind-the-scenes look at how we do things here at the Mesonet. The Oklahoma Mesonet is a statewide network of 120 weather observation towers, each working together to give us a picture of the weather conditions across the state. Each tower is equipped with multiple different sensors that all send data back every 5 minutes, every day of the year. These sensors are all calibrated rigorously to ensure they meet research quality standards here at the National Weather Center. Let's head inside to the lab to see how that process is done. We don't wait for instruments to fail. We use active QA, where QA meteorologists and computer systems are checking the data to make sure the values are in line with expectation. We also use rotation intervals. A sensor will only spend a certain amount of time in the field before being brought back to the lab, cleaned, recalibrated, and then finally sent back out into the field. We use a number of different machines in the lab to calibrate sensors. This is one of them. This chamber is where the Oklahoma Mesonet air temperature sensors get calibrated. These sensors work by the logger taking a measurement of resistance across the tip of this platinum sensor, and that resistance value is proportional to air temperature. Inside the chamber, we have a stirring fan inside this manifold, which keeps the area where the sensors are nice and constant as we change the temperature between -40 and 60 degrees Celsius. We have the test sensors mounted alongside reference sensors, and at the end of that process, we compare the two to make sure that they're within 0.1 degrees Celsius. In addition to measurements above the surface, we also perform soil moisture and soil temperature measurements below ground. The soil temperature side is performed in this chamber here. Now, similar to before, we have a stirring fan and a manifold inside, and we'll mount the soil temperature sensors along with a couple reference sensors inside. And then after we change the temperature between -40 and 50 degrees Celsius, we can compare the two and make sure that they are within 0.1 degrees Celsius of each other. In this system, we calibrate the Oklahoma Mesonet barometers. So we change the pressure inside here between 700 and 1100 millibars, the entire range of pressures that barometer could experience, while also changing the temperature between -20 and 50 degrees Celsius. So we compare those barometers against a reference to verify that they'll work during weather conditions across Oklahoma. This device is a data logger. It kind of acts as the brain of the site, controlling when and how each measurement is taken. It interprets the electrical signals that come from the sensors and translates them into values we care about, such as air temperature or wind speed. This is a Mesonet soil moisture and temperature sensor. It's a ceramic encased thermocouple with a heating element, and we can get soil moisture values by applying heat to the sensor, taking a temperature before and after, and then using the thermodynamic properties of water, we can determine the moisture content of the nearby soil. The calibration is straightforward. First, we dunk it in water for about 7 days to find the moist end of the sensor, and then we do the same thing in a bag of desiccant, stick it in there for about 7 days to find the dry end of the sensor. And then we use that calibration to determine unique coefficients for each sensor. Each Mesonet site also has 2 rain gauges, just like the one you see here. Now, each of those is composed of 2 main components. The first one is this 12-inch diameter funnel. Inside, it just has 2 screens to keep bugs and seeds, things like that, outside. The second major component of the rain gauge is the tipping bucket. Rainwater falls from inside the funnel into the tipping bucket, and then eventually the bucket will tip, resulting in 0.01 inches of rainfall being recorded. Now we have to calibrate the gauge so that each side of the bucket holds exactly the correct amount of water before tipping. Another variable measured by the Oklahoma Mesonet is incoming solar radiation. And these sensors are photovoltaic detectors. The output of the sensor is a current which is proportional to the solar radiation. We calibrate them indoors here at this facility. We have a lamp mounted above that outputs a known irradiance. And then we have a reference sensor located next to a test sensor. And we turn the lamp on, take a measurement, swap the sides to average out any difference in levelness, and then reverse the process to make sure we get a stable coefficient for calibration. We're back outside at the National Weather Center Mesonet Tower. I wanted to talk about the wind speed observations we take here at the Mesonet. This is an example of our 2-meter wind speed sensor. It's a cup anemometer, but we also have a 10-meter wind direction and wind speed sensor above me. We calibrate these sensors here in Norman with a bunch of different mounts with a reference sensor in the center. So we'll put a bunch of sensors up at once, let them go for about 2 weeks. We want to make sure we get some calm winds to test the starting thresholds, along with some stronger winds to test how these sensors perform. When that process is complete, we bring them back to the National Weather Center and produce error plots to make sure that that data is within specification. As you can see, a great deal of time and effort goes into ensuring that our instrumentation provides the highest possible quality data to public officials, emergency managers, agricultural producers, and the general public. Thanks so much for joining us on the tour of the Oklahoma Mesonet Calibration Lab, and we hope you enjoy the rest of the 2020 National Weather Festival.